So sine of theta is equal to the opposite over the hypotenuse. That's what the O and the H stand for, the opposite side over the hypotenuse. C stands for cosine. Cosine of theta is equal to the adjacent over the hypotenuse. That's what the A and the H stand for. And then the TOA is tangent of theta is equal to the opposite over the adjacent. Okay, so that's what those letters all stand for. Now, you've got to be able to label the sides of the triangle to be able to use these trig ratios properly. So here are a few things that I do. The little right angle, the square that indicates the right angle there, the corner always points to your hypotenuse. Okay, the corner always points to the hypotenuse. Now, to decide between the opposite and the adjacent sides, here's what I do. I draw a curve around the angle that is marked. That curve always touches the hypotenuse, and it always touches the adjacent side, because think about what the word adjacent means. If you are adjacent to something, you are right beside of it, or you are touching it. So that's the adjacent side, and then your opposite side is the odd man out. Right? It's the one that neither of those touch or point to. So let's look at this one. We want to know the opposite. We know the hypotenuse, so we've got O and H. So O and H is sine. So the sine of the angle, 64 degrees, is equal to the opposite. That's what we're looking for, x over the hypotenuse. We know that value is 25. We're solving for x. Right now it's being divided by 25, so the opposite of that would be multiplying by 25. Just for clarity's sake, I'm going to write that expression. I didn't change anything, I'm just rewriting it to show that that is equal to x. Now, your calculator should be set the way that it needs to be, but just to make sure, because some of y'all are in the habit of resetting it, or some people in my other class are in the habit of resetting it, click mode. Okay, mode is the button beside the yellow one, second. Okay, when you go down to the third line there, degree should be highlighted in black. If it's not, then move your cursor over there and press enter, and then press second mode, and you'll go back to the home screen. Okay, you have to be in degree mode because our angle is in degrees. That mode is telling your calculator how to interpret that angle. If it's in the other mode, then it's interpreting it as a different measure of an angle, and it's going to give you the wrong number. So we're supposed to round to the nearest tenth, so 22.5. We don't have any units, so we'll just leave it as 22.5 is approximately our x value. Tomorrow we will find out what radian means. All right, number 2. Let's look at number 2. The right angle, that corner points to the hypotenuse. So we're not looking for the hypotenuse. We don't know the hypotenuse. Go to your angle, draw your curve. It touches the hypotenuse and it touches the adjacent side. So that means 12 is adjacent and x is opposite. So we want the opposite. We know the adjacent. So O and A is tangent. Tangent of our angle is equal to the opposite x over the adjacent 12. Solving for x, same as before, we just have a different trig ratio. We're dividing by 12, so the opposite is to multiply both sides by 12. Just for clarity, I'm going to write 12 tangent of 47 is equal to x, and then I'm going to go to my calculator and compute that. 12 tangent of 47 is 12.9. That is approximately the value of x. Now let's talk about, really quickly, making sure that our answers make sense. This is something else you would catch, or how you could catch if you were in the wrong mode. If we look at number 1, hopefully you remember that property about triangles, that the longest side is always across from the biggest angle. So that's why the hypotenuse is always the longest in a right triangle. So if 25 is the longest side, then both of our legs should be less than 25. So we're good on number 1. On number 2, now we don't have the hypotenuse, so we can't relate it that way. Our answer was 12.9. So let's think about these two. If this is a 47-degree angle, then our other angle is 43 out of 180, right? We've got 43 there. So if the side opposite of 43 is 12, then the side opposite of 47 should be a little bit bigger, but not much bigger because those angles are pretty close in size. So 12.9 makes sense there. All right, number 3. Let's look at that one. Right angle always points to the hypotenuse, so 34 is our hypotenuse. Draw your curve at your angle, so it touches the side labeled X. So adjacent and hypotenuse, that would be cosine. Cosine of 18 degrees is equal to the adjacent, that was X, over the hypotenuse, that was 34. Same case, dividing by 34, so the opposite is multiplying by 34. I'm not going to rewrite it this time because I think we're getting the hang of it. 34 cosine of 18, 32.3 is approximately X. Okay, a couple more. Number 4. Right angle points to the hypotenuse. Draw the curve. It touches the hypotenuse and the adjacent. Odd man out is the opposite. So we know the opposite. We want the adjacent. Opposite and adjacent is tangent. So tangent of our angle is equal to the opposite 9 over the adjacent X. A little different here. Our variable's in the denominator. Go back to the warm-up for a second. We want to get the variable out or solve for the variable. We got to start by getting it out of the denominator. Multiply both sides by X. Turn around and divide by tangent of 35. So let me rewrite that before we put it in the calculator. And mention what really happened here. Okay, it was originally 9 over X. Now it's 9 over tangent of 35. The tangent of 35 and the X just switch places. Okay, so that's a shortcut that you can use, but I wanted you to see where that comes from and not just use the shortcut. Why do they switch places? Well, because you multiply and then you turn around and divide. So X is approximately 12.9 here. Okay, let's do 2 more like that. Number 5. Right angle points to the hypotenuse. Draw your curve, so that's the adjacent. So 27 is opposite. X is the hypotenuse, so opposite and hypotenuse is sine. Sine of the angle is equal to the opposite over the hypotenuse. It goes the same way every time. You're going to multiply by X, and then you're going to turn around and divide by the trig. So just go ahead and switch places. X is equal to 27 over sine of 63. 27 over sine 63. X is approximately 30.3. Makes sense? It's bigger. That's the hypotenuse length. So that's bigger than our leg that they gave us. So at least that much of it does work out. All right, last one, number 6. right angle points to the hypotenuse. So the hypotenuse is x. Draw your curve. The curve always touches the hypotenuse and the adjacent. So 18 is the adjacent. So that's cosine because it's adjacent and hypotenuse. So cosine of the angle, 30 degrees, is equal to the adjacent, 18, over the hypotenuse, x. Switch places. X equals 18 over the cosine of 30. Oops. Okay, so we get approximately 20.8. Again, make sure it makes sense. It's the hypotenuse, so it should be longer than the leg. Now, let me show you. I don't want you to change this in your calculator, but I'm going to change mine back to radian. Say for this last one, I was in radian mode instead of degree mode. So I get 116.7 for my hypotenuse. Now, it's supposed to be longer, but does it make sense that it would be that much longer? Probably not. Okay, you can't always trust the pictures, but these are drawn purely to scale. That should be a 30-degree angle. So you can tell this leg, yeah, it's longer, or the hypotenuse is longer than this leg, but not by that much. Shouldn't be 116 in length. So just make sure that's what I'm talking about when I say make sure that your answers make sense. That did not make sense. 20.8 is much more reasonable. Now, that's not to say that we can't have big answers. Just make sure that relative to what you're given, it makes sense.